In this video, we're going to generate a starter Spring Boot application and run it as a Docker image. We'll be using Ubuntu Linux. Let's start by creating a Spring Boot starter project. We'll use the command line tool curl to generate the starter project by going to https://start.spring.io/starter.tgz and pass in the options -d type equals maven project and -d dependencies equal webflux, actuator, and then -o demo.zip to save our output. Once that's done, we'll run tar xvf demo.zip to extract our output. Let's take a quick look at the project and see what was generated. We can use VS Code to do that by running code space dot in the current directory. Demo application.java is the entry point into our application. This is the default code that's created for us. There's really nothing special here. In the POM file, we can see our Spring Boot starter dependencies were added for actuator, webflux, and test. So all in all, a very simple, plain vanilla Spring Boot application. Let's close out of this code and run ls to see what files are in the current directory. First, we're going to build our project as a self-running jar. To do that, we'll use the maven wrapper script mvnw and the goal install. The install goal will compile our project, run tests, and package our application as an artifact. And in just a moment, we have the message build success. Let's change to the target directory. We see a jar file was created. Let's run that as a self-running jar by typing in java-jar demo 001 snapshot.jar. Our application starts up and we can see that it's listening on port 8080. Let's open up another terminal window and hit that endpoint. To do so, we'll use the curl command. So we'll curl to localhost :8080/actuator. Actuator exposes endpoints for monitoring the health of our applications. And we'll pipe that output to python3-m json.tool. The Python code will pretty print the JSON output from the actuator endpoint. This JSON output provides links to the actuator endpoints to get information such as the health of the application. All right, so at this point, our application is running as a self-running jar and we hit the endpoint. So really no different than many of the other projects we built here on the Begin Secure channel. Let's terminate our Spring Boot application. Now we're going to package our project as a Docker image. First, let's run Docker images to see what images exist. If you get a message like this, permission denied, it means you don't have root level permissions to run the Docker command. So instead, type in sudo space docker space images and enter the password for the admin. Right now, I have no images on my local system. Now let's package our application as an image by running sudo, because we'll be writing our Docker image to our Docker repository, maven wrapper, and we'll specify spring-boot build-image. This goal is from the Spring Boot Maven plugin. It uses cloud-native build packs to build a Docker image from our jar. The resulting image will follow many best practices, including using a non-root user and efficient layering. And in just a moment, we get build success. Notice we get the message, successfully built image, and the name of our image. So now if we run sudo docker images, we can see that our demo 001 snapshot.jar has now been created as a Docker image. Let's run our image by typing in sudo docker run -p 8080:8080 to map the port of the host to the container, and then the repo and tag of our image, demo:001 snapshot. Our image starts up and we can see the same Spring Boot log information, including the fact that it's listening on port 8080. Now let's go back to our other window and run the curl command and pretty print the output. And there we go. We can see that we get the same output whether our application is running as a self-running jar or as a Docker image. All right, that's all for this time. Thanks for watching, and remember to always begin secure.